will enjoy it. Thank you.
The All India Plastics Manufacturers Association is proud to launch Arvind Mehta Technology and Entrepreneurship Center in Mumbai with the core objective to help the plastics and its application industries in becoming globally competitive. The center would be the hub of latest technology and innovative solutions required by the industry to manufacture best of the products at highly competitive cost. The center would also be the breeding ground for students and startups in the field of plastics and its applied industries. Looking at the need of the industry to increase speed to market, APMA's MTech is setting up Center for Excellence for Plastic Product Innovation and Application. APMA's MTech, Center of Excellence for Plastic Product Innovation and Application. Main vision behind setting up Center of Excellence is to promote high-quality knowledge and industrial services for rapid growth of the plastics and its application industry. State-of-the-art Product Innovation and Application Center would consist of high-quality equipment and leading national and international knowledge partners. Our goal is to help the MSMEs in reducing overall time to design, develop and rapid rollout of products, thereby increase speed to global market and compete with China in global market. The center would address various challenges faced by the industry in the areas of reduce product development lead time, help deploy right technology, enhance productivity, make products market ready, improve quality cost delivery, upskilling and training workforce, improve APMA's MTech Zeiss Center for Reverse Engineering. With the help of Carl Zeiss, the center would offer programs and industrial services for reverse engineering. Zeiss products such as CMMs and 3D scanners would be used throughout the process chain. Targeted component and tool analysis of prototypes can be performed, as well as inline quality control inspections, thus ensuring an optimized production process. The training and services would lead to speed to market, reverse engineering scanning, design and prototype, increase efficiency, productivity, and cost of production. APMA's MTech Center for Additive Manufacturing, with the help of leading international technology providers and our knowledge partners, we are launching digital manufacturing. This is expected to lead to low-cost prototype development, low-volume production, and speed to market. Demand for skills in additive manufacturing is growing exponentially. APMA's MTech SSA Center for Industrial Management. The center would offer strategic management and marketing advisory services for startups, MSMEs, as well as corporates. A team of experts would support startup entrepreneurs and MSMEs with inputs to enhance their competitiveness for the local and global markets. This center would extend benefit to help the industry in practical implementation of projects with increased profits. Also help
Thank you. So we are live now, and we will start with this PPT. So let me just introduce Miss Amaya Zada. She is our center head, and she will take forward from now. So handing over to you, ma'am. Please take it forward. Thank you.
Thank you, Nikita. So on behalf of APMA's MTech, myself Amaya Jadhav, I welcome all of you for this 3D printing webinar. I welcome Mr. Paresh Bhidaji for this webinar, our speaker. So it gives me immense pleasure to introduce our today's speaker, Mr. Paresh Bhidaji. He is a director of Protosys Technologies Private Limited, which offers complete end-to-end services for the new product development activities, including designing, prototyping, mold manufacturing, and injection molding. He has been a pioneer in the field of 3D printing in India as Protosys was the first 3D printer service bureau to offer parts on a Stratasys 1650 FDM printer way back in 1996. So with over 25 years of experience in this additive manufacturing, he has been associated with many new product development companies over various industry segments like HUL, Marico, Tata Motors, Philips, Siemens, etc. So over the years, he has been instrumental in the growth of Indian 3D printing industry by sharing his experience and expertise to young startups and 3D printing machine manufacturers in India. And we are very fortunate to have the speaker and Mr. Pareshi, and he is also the member of managing committee member of APMA, All India Plastic Manufacturers Association, and the technical committee member of APMA's AMTech, that is Arvind Mehta Technology Entrepreneurship Center. So on behalf of AMTech, APMA, I welcome you, sir, for this webinar. Over to you, sir.
Thank you very much, Amaya, for such a fantastic introduction. Very good afternoon to all of you. Myself, Paresh Beda, as Amaya has introduced me already. Today I'm going to take you through the journey of 3D printing in India. So before moving into, one second, let me share it. Yeah. So is the screen visible?
Yes, sir.
Yes,
Yeah.
sir. You
Yeah.
can full screen it.
Yeah. So I'll take you through this journey of 26 years of 3D printing services in India. So before moving to Indian 3D printing industry, we need to know the creator of 3D printing. First 3D printer was invented by Mr. Charles Hull, who is also called the father of 3D printing. He invented SLA technology way back in 1986, the first machine based on stereolithography technology. So moving on to our Indian history, FDM later on after 3D Systems, Stratasys was another company which came out with a FDM technology in 1992, and Protosys is proud to inform that Stratasys was the first company which Protosys joined hands and brought in the first 3D printer in India for commercial services 26 years ago in 1996. So here on, I'll take you through the milestones of 3D printing in India. As I told you earlier, the first 3D printer for commercial services was imported in 1996. The SLA 3D printer came back in around 98, 99 in an automotive company, followed by SLS printer. SLA printers were good for accuracy and surface finish with fine detailing. So jewelry industry in India found fancy in that, and the initial machines were installed more into jewelry industry than in our engineering industry, especially for SLA printers. The size of those machines initially were 250 by 250 by 250 cubes, so small machines, but fantastic feature definitions. Protosys came out with 3D printing application in medical modeling long back in 99 2000, wherein a CT scan data of a patient was taken in and converted into a 3D model, which doctors used to uh, use for their study for planning of the surgery before operating on the patients. So that helped them in reducing their operation time by almost 40%. In 2009, the first patent of FDM printer got over, and we could see lots of FDM and FFF machines being launched in India and abroad at a fraction of price than what Stratasys used to offer. Later on, Chinese manufacturers reverse engineered the FDMs, the SLA, SLS, and they started flooding low cost machines into the worldwide market. Currently, if you see the technologies which are very popular are SLA, that is called stereolithography. Then we have SLS, that is laser sintering. Then we have FDM. Then we have multi-jet fusion technology, which was launched by HP a few years back. DLP, it's a very small but a very beautiful machine. We can see that machine in our AIM Tech Center. It gives very good parts in very tough and strong materials, including materials which can take up to 350-degree temperature. Then in metal sector, we have DMLS machines which can print directly on the metal powders using laser-based technologies. So I'll go through few of the machine technologies in details, explaining the principles on which they work. As SLA technology works on laser-based technology, which converts a photopolymer liquid resin into a solid plastic by solidifying using a laser beam. You can see here, the part is seen in the liquid bath, where in the bottom there are supports and the black portion what is seen is cured by laser beam, and slowly and steadily from bottom to top, the part goes on being built. The SLA process offers mainly two basic raw materials. One is opaque, which is ABS based material, and another is transparent, which is acrylic equivalent material. So the advantage, very good finish, detail, geometry detailing is too good, and you get extra smooth finish can be achieved. Few of the samples done through SLA process. You can see this very fine features of an connector, electronics connector, the translucent part which can be finished to get a transparency. Secondly, we have selective laser sintering process, which uses CO2 laser to solidify a powder-based material which is coated layer by layer, and same as SLA, the bottom to top approach, the part gets built after layer by layer. The material comes in and the laser cures that area what is important to us. The advantage of SLS is you get very good strength parts. The raw material used here is nylon and glass fill nylon. So at times you can use those materials directly for end use or easily used for functional trials. The only limitation or drawback is the surface finish is comparatively poor due to powder-based technology. The next, you can see some of the samples done in SLS. The next is the widely used FDM technology, or it's a fused deposition technology, what is called. It uses a thermoplastic filament which gets heated in an extruder, and the plastic wire type of material comes out and it is laid layer by layer to create a 3D model in few hours. FDM is the process which has lot many options of raw materials wherein you can use PLA, ABS, nylon, PC, and even high-end engineering plastics like Ultem and Peak. Drawback of this technology is the poor finish and accuracies. You can see the layer marks on the sample, which are quite visible compared to the samples in SLA and SLS. But the FDM is a technology which is quite economical, and you can see those printers available at every place. The next technology we can talk about is MJF, multi-jet fusion, which is being popular in India in last few years. It's because of its strength and the surface finish. The principle of MJF is it uses again a powder similar to SLS process, but instead of laser, here you can see it's a fusing agent and a detailing agent are um, jetted through printer heads, and the part is formed again by layer. Lamps are used to cure that, and the process continues layer after layer. You remove the powder and part is ready to use. The advantages, as I told, are because of the strength and finish. You can use it directly as an end-use parts. You can see the samples here, photographs. They have beautiful finish compared to SLS, and the strength also. They have options of nylon and glass field nylon. Two different materials are available. Next, we move on to DMLS or a direct metal laser sintering. Here the process or the principle is same as that of SLS process. Instead of a polymer material, here we can use steel, aluminum, titanium, Encolil, different kinds of all type of metal powders which are available in the market. The advantages are you can get end-use parts directly, wherein your short-run production parts are required. You can directly use them uh, for direct use. So DMLS parts currently are mostly used in aerospace, defense, tooling, and medical applications. Next, I would like to share some of the industry verticals where 3D printing is widely used. This is not the whole list. This is some of the list which I am sharing here. We started in 96 with automotive appliances, switchgear, and these companies way back in 96, and slowly graduated to uh, aerospace, defense, toys, medicals, tooling, and in the new generation, the drones, electronics, PCB manufacturing. We are seeing now 3D printing being used in construction. Customized medical implants have already started, and another major uh, uh, field which we are seeing in future is tissue printing, where a patient can get his liver printed and get transplanted into his body. Those days are not very far off. Scientists and engineers in India and abroad are working on this. So we will see lot many interesting things coming up in industry 3D printing applications in years to come. Now, I would explain few of the industries where we using some samples. Automotive is the major consumer of 3D printing industry, and almost 40% of the 3D printing industry is being supported by automotive companies. In India, if you all major automotive companies have captive machines like Tata Motors, Mahindra, Bajaj, TVS, Hero. They all have in-house machines and they equally offload the jobs to the service providers like us. So any automotive a vehicle, is it a two-wheeler or a three-wheeler, you will find the prototype vehicle being built first using 3D printing technology, and then only the formal tooling and the final vehicle is launched into the market. If you, for example, for a car, if you see all the interiors, the IP, the seats, the mirrors, in the exterior, you see different kinds of lights. Even the engine compartment has many parts which are 3D printed. So you cannot think today a vehicle being launched without prototyping used using 3D printing. It's just impossible. That's the impact of 3D printing on automotive industry. Industrial parts everywhere nowadays, 3D printed parts are being used. Either it is MJF part, SLS parts, or you go through a secondary process of vacuum casting. You see lot many parts being used. Uh, Electrical switchgear industry, you see every few months we see fancy switches coming into the markets. So without 3D printing, again, it's very difficult for them, the manufacturers, to launch different products in such a short time. So uh, there are endless applications of this packaging industry. If you talk about, we see different kinds of bottles, caps. So a designer can think about various designs without being held up of whether that part will be manufacturable or not, by if his tool will be successful or not. He gets the prototype done and then he can evaluate whether this product is worth manufacturing, or whether it will find out come across some technical challenges, and then they can move ahead with regular productions. Electrical appliances, for lots of applications over there. It's for form, fit, functional trials, even for marketing, the samples being given for test marketing based on the feedback coming from the consumer base, the modifications done, and then the final products coming into the market. IoT-based enclosures are picking up in big way, where 3D printing is helping them. The new startups they are coming up with, they don't want to invest in the tooling in the initial stages, so they go through this process, get their product approved, and then they will go for the mass manufacturing. Toys and gifting, you can think about different toys and ready to use. In a few hours, you can design a toy and 3D print, and it can be used. Lots different ways of creating new toys are coming up due to help of 3D printing. People can think of different options of uh, designing in different ways. 3D pens, the kids uh, are using this in the schools nowadays. 3D pens can enhance the creativity in kids to create and execute exciting designs. So they today they are just drawing on paper. Just you can imagine that same thing coming live in a 3D format using these 3D pens, which are now readily available everywhere, even in India. And many schools have adopted this for their students in the curriculum. Medical, as I was talking about, these models, what you see are pre-operative models. A skull with a defect. On the right hand side, you can see uh, a face which has having some defects, some cracks. So the doctors can plan the whole surgery on this before they actually operate the patient, and they can plan what type of implants are required, or even they can design the implants, which can be seen in the next sheet. Here you can see a titanium implant has been designed using the 3D model. On the right, you can see a template created, and then whole this 3D printed stainless steel implant has been used in a patient, which is accurate and exact. It is as per the data received from a CT scan data. So this is a very big application of 3D printing in for medical field. Another exciting application is 3D printing directly for making molded components. For a very short run production, if you're looking at making 20, 30 samples in actual material, you can create a core and cavity of a product using 3D printed 3D printing machine. You can see this core and cavity is developed and fitted in a regular mold base, and then this is taken on a molding machine to produce maybe 20, 30, 40 samples in polypropylene or HDPE type of raw materials. You cannot use very high temperature materials into these molds, as the life of this mold is less, as it is a plastic based core cavity. But definitely for initial concept proving, it can be very useful. The very exciting example or application which for plastic industry is through for a DMLS process is the conformal cooling for tooling inserts. If you can see this colorful channels, what you see are the cooling channels which cannot be manufactured using any conventional process. It's any shape you can design for a better cooling of a channel as a mold. You can design it, and it can be 3D printed through a metal sintering machine, and you can use that tooling insert into the mold. Uh, we can achieve anywhere between 15 to 30% of cooling time reduction. Cycle times getting reduced by such a huge percentage, which can result in more productivity in the injection molding. This technology is picking up in a big way in India recently. More and more tool rooms are trying to adopt this technology, and we'll see, especially in plastic industry, this the benefits of conformal cooling in the long way to go, especially in injection molding arena. After going through all this processes and applications, I would like to now mm, take you through these 4 ways of AIM supplementing conventional manufacturing. Conventional manufacturing, 3D printing is not going to replace conventional manufacturing. It is going to complement and supplement it. Wherever required, AIM is going to be useful in enhancing all these 4 parameters, what we are going to see in details. Quality. Over the years, we have seen improvement in print quality. Machine reliability has increased for 3D printing since 96, when we had only one machine with only 2 different materials. We could only print in ABS and wax. Today we have multiple material options available for different technologies, which have better surface finish, better dimensional qualities, and better usability. We have materials, as I told, which can be directly used for end use. DLP is a technology. Figure 4 from 3D System offers excellent feature definition parts, which can be directly used for end use purposes. You can create complex designs and shapes without any constraints of manufacturing for a short run production. So in term, we can have better quality products in the market. There has been lot of improvements in software, uh, and we can see the improvement in surface finish of the parts, and even the time has been reduced, where software have been the newer softwares can branch the parts in such a way that the productivity improves in a better manner. Speed. Today, speed to market is of great essence, and 3D printing has helped the new product development companies in a big way to launch their product into the market in a big way. Earlier, a new product used to take 6 months at least to see the market. Today, the products are launched within 30 days or 45 days. And that could not have been possible if the designers who are designing their products have that samples in front of them in a very short period, which could was possible only through 3D printing. You design a product, and within a 24 or 48 hours, you have a sample in your hand. You can assess that sample, make the corrections, get the second iteration done. So uh, the final drawings which are released for the tool making, you are sure that there is not going to be any corrections coming up. So 3D printing has helped a lot in getting the new products into the market very fast. Efficiency has drastically improved using 3D printing technology. Indirectly, if we talk about it, the if I give an example, a few years back, we had developed one prototype for an appliances company which was supposed to come out with a product which is a seasonal product. But instead of going directly through tooling, they came for us to us for a prototype. And once the prototype was delivered to the customer, the marketing team just threw that sample saying that design was hopeless and it is not going to work in the market. Just imagine if they had come out with that product after making a tool, they would have lost that whole cycle of that product. They saved that uh, cycle of that product. They could immediately design a new product which got approved from the marketing team, and they developed that tool, and they could come in the market within time, and to save that cycle season. So streamlining of supply chain, if you see directly, you can say what help it can be doing, but indirectly, the supply chain management has been much more affected by 3D printing. The agile approach, continuous improvement. We are seeing worldwide now the products have to be continuously improvement. You cannot have a ambassador or a Fiat. You come out with such products and then try to rule the market for 10, 15, 20 years. Here you have to come out every day with new products, and nothing you can have more efficient products without the help of 3D printing. Creativity, another aspect. You think you can innovate designs for a short run production. I would say I want to give some out of the box gift to someone which is not easily available in market. I can design that and directly 3D print, and it can be given to the end user. So creativity is at the best when you have a support of 3D printing. Many new materials, as I told, are coming in. A few more, the development is still happening. So, second, one more application is like collaboration between teams. One team is sitting in Germany, second team is sitting in India, and if you want to develop a product, just through drawings and discussing on the drawings is not going to help. In a way, if they have samples, both are having samples, they can go through the nitty-gritties of each and every detail and come out with a product which is highly effective. So, saying all that, there are still some challenges in 3D printing over the years. It were during those days, and even now we have those challenges. Cost, the pre and post processing cost were even there during those days, and even now we have those challenges. Raw material cost, I will tell you, we were using ABS steel in 1996 at 22,000 rupees a kg. It was a bomb. Today, if we tell someone that 22,000 rupees kg was the raw material cost, they would laugh at us, because now the spool, ABS spool, what we use is around 800 to 1,000 rupees a kg. Still costly, but compared to that, it is nothing. Cost of 3D machines at those days were bomb. It was very costly, very limited machines available. Technology limitations, as I told, finish was not that up to the mark. We used to have do the proper finishing. Customer awareness, it was like, I would like to give you an example over here. We had participated in one exhibition uh, at Godrej around 96 or 97, I'm not very sure the exact year. We had displayed some samples. The customer, someone came on our stall, we showed him sample and told him that, see this sample, it is made without making a mold. He just replied back saying, "क्या आप झूठ बोल रहे हो?" It is, you're speaking lie. It cannot be possible that a plastic product can be developed without making a mold. So that was the awareness during those days. So it took us a lot of challenges to create customer awareness that there is a technology which can directly print parts. Part quality and finish, as I told earlier, there were a lot of limitations in those days, but now things have improved a lot. From two materials for FDM technology, we have now 10, 15, 20 different materials in uh, FDM technologies. Still, the costs of the machine, the industrial printers are still high. Limitation of raw materials for SLA, SLS are still there. Size limitations are there. You cannot print a 1 meter part. If you have to print, it is not that easy. You have to make in parts. Scale up is, again, you if you want to scale up your business, it is a challenge. Even today, we don't have a service bureau which has around 10 machines in house of the industrial category for engineering purposes. Jewelry, you'll find many. The desktop small FDM printers, you'll find many. There are FDM farms nowadays where you see 50, 70, 80, 100 machines being installed, but mainly those are for non-functional parts and more. For in-house machines, where people are using in-house machines, still people having problems with having a good personnel, good technical staff. Even in bigger companies where automotive and they have the in-house machines, they have these challenges of not so expert personnel in-house. They still have to depend on post processing outside for better quality parts. They still outsource it. That challenge is there because we don't have any formal 3D printing subjects being taught in any of the universities. So AMTech has taken up that challenge. We have started in AMTech a course on 3D printing. Hope that will bridge the gap of providing a proper trained personnel to the industry. Future of 3D printing. We spoke about the past, the present, future. 3D printers are getting bigger, faster, and cheaper. The cost of the first Stratasys machine, what we had bought, and today what 3D printers are available at very, very low price. Even SLA printers have come down a lot at the similar sizes. What we could get a 250 cube machine, today we can get a 600 by 600 machine at maybe that or a lesser price. Chinese machines have come down, they have brought down the prices. End use parts, as I told, supply chain will definitely, it will impact the supply chain when we can give actual end use parts directly to 3D printing. Your cycle is your what you call product line is stopped due to something. You need some parts immediately, and for that, then you can immediately print some parts, provide it so that your uh, down the line cycle doesn't stop. Every technology has its own USPs. Some have better quality, some have better strength, some have cheaper options. So we do not have any one technology which can cover everything. So we'll have to live with that. In future, we may expect something. We are seeing such technologies being developed uh, in from next exhibition in Germany. Arburg had displayed one machine wherein you just bring any type of pellets, whether it can be a PP, it can be a PC, it can be nylon. You just put in the pellets, the extrude, and you get a part in any kind of machine. We are looking forward if that technology comes in. I think if that becomes popular, it will change the whole way the world will look towards 3D printing, because then there will be no limitation of material. You put in any material and it will print it. Some of the future 3D printing applications I would like to share. On the right, you can see a 3D printed house built by our own IIT Madras startup. So it's not just abroad. 3D printing in construction has already taken up in India. We'll see more and more buildings coming up in near future. Drones, as I told you, that the newer materials, like we have carbon filled materials, we have fiber filled materials, some machines which offer this materials to be built. So that has reduced the weight of the parts, and the strength of the part has increased. So a drone has a very good example for those type of materials which has reduced the part weight and increased the strength. So we'll be seeing those type of technologies or the machines being more and more used in future. Other than drones, maybe fixtures, tooling fixtures, where it will replace the aluminum or metal fixtures, and we will be using such lightweight fixtures. 3D printing in aerospace and defense is already there. On the left, if you see the part, it is quite complex part which cannot be manufactured using a traditional way. You can see there are so many complexities in that. Few parts merged together has been built in one piece, and that can be possible only through 3D printing. So it is lightweight and a fully functional prototype. Maybe it is used in either aerospace industry or defense, where there are challenges. A new product launching takes years and years, so this can bring it down. On the right hand side, if you can see, there are two samples. One is manufactured using in conventional way, it is a solid part. On the right, you can see it is manufactured using 3D printing, it's a lightweight uh, part with lots of air pockets created in that. It has better strength than the solid one and a lighter part. So today we are looking at vehicles or aeroplanes, or the main funda is being light, light, and light. So we 3D printing is definitely going to help them in getting those weight reductions. 3D printing in electronics. This is another fantastic area in future. You can print any PCB in a matter of hours. Any shape, size, design can be 3D printed. Don't depend on others or mass manufacturing. You are trying to develop something, you just want, you have designed some electronics, just print it, use it, revise it, go on iterations. So we looking forward to see it in big way in electronics. Now we come to the scope of 3D printing in India. Over the years, we have been seeing that 3D printing still has not picked up in a big way in India. If you compare to China or any other developing countries, we are still way much behind. But with Make in India campaign, which has been started by our government, if you see in last couple of years, the toy industry, we are seeing toy parks coming up in various parts of India. R&D in defense, the government is promoting Make in India in defense, where will our in defense budget is so high if we can cater to that. I think that is going to be a very big game changer for Indian 3D printing industry if we can cater to two big industries, that is military or defense and toy industry. Toy industry is booming like anything, and it's unbelievable. Today there is a company in Bangalore which caters to 8 international brands. They have 350 injection molding machines in-house with zero sales in India. They all are only supporting international brands like Mattel and Hasbro and all those brands. So you can just think about what can be in India. And 3D printing is definitely going to help in that. Fashion wear. You will be seeing fashion accessories, footwears, even the dresses of 3D printed being printed and used, wherein you are looking for some uniqueness. So medical is another field. Education industry is going to be big where 3D printing can. So anyone here who is thinking about putting up a 3D printing setup, they can think about innovative applications, not what is being currently happening. Don't go into the rat race. You will have to come out with something very innovative. With this, I think, sorry. Yeah. Uh, I end my presentation on 3D printing journey over here. I'll take you to our APMA's AIM Tech, what we are doing, and how we are trying to help the Make in India initiative. So I'll take through this. AIM Tech, it is called Arvind Mehta Technology and Entrepreneurship Center. It is being promoted by All India Plastic Manufacturer Association. The setup is in Andheri MIDC. All are welcome to see over there. Come and have the look at the setup. It is an approved training center by Skill India, NSDC. So all the training courses that are happening over there, I'll share you the list of training courses that happen over there. 3D printing is one of the course that is happening over there. We have reverse engineering, then we have training of NX, through Siemens. That training courses are going on. We have special prizes for students and the industry personnel who want to upgrade or upskill themselves. 3D printing courses are there. It's if you see that 70-hour course is just for 15,000, and this will definitely help the gap what 3D printing industry is looking at. Jewelry, we have special courses for jewelry too. We are coming with a roundtable conference on 13th of January, where we are having speakers from IPI, Society of Plastic Engineer, Tata Autocom Systems, Udo. So they will be sharing about their knowledge, their experience, what they have learned in so many years, and how the technology can help you in the near future. Thank you very much for listening to me, and now I am open for the questions.
Hi, sir. So I do have some questions over here. So let's just make it quick because our session should be getting over by 4:30. So let's just make it quick, okay? Mr. Pankaj had asked which PP material is used in 3D printing. It's PPHP/PPCP.
See, right now PP is only used, but again, processing polypropylene is a very difficult task. So very few people are using PP on FDM machines. And it's still, as I told you in example, it was mainly PC, ABS, PLA. But yes, PP is being used, but it is not PPCP, it is normal PP.
Okay, so the next question is asked is are there any technologies for mass production?
Yeah, there are some machines which can give you end use parts, but not mass production, because until and unless the raw material prices don't come down, it will not be viable for a mass production. See, today we get end use parts from figure 4 machine, what I was talking about. It gives a good quality strength parts, but the raw material cost is around 20,000 rupees a kg. When you're looking at mass manufacturing, the plastic which are commercially available, they are available at 100, 150, 200 rupees a kg. So you cannot compare these technologies right now for mass manufacturing unless we get materials which will come down in a bigger way for the costing.
Okay, so Mr. Prashant Verma has asked which 3D printing method and material is best suited for plastic samples?
See, it depends on your application. All the technologies, what I explained right now, have their own USPs. So, what is your end use? What is your purpose? Depending on that, you will have to select a technology.
And he has also asked for which 3D printing machines make is best suited for print prototyping.
See, the same thing again, all the technologies are used for prototyping. These machines, whether it is SLA, SLS, FDM, all these machines are initially they have been launched for making prototypes only. So, depending on what is you want to use it for, no single technology is going to serve all the purposes. Either if it is for your own captive use, you have to select what is going to be my best option and you go for that. If you are looking at as a service bureau point of view, you will have to have all these technologies under your roof. Then only you can satisfy the customer.
Okay, and Mr. Purval wants to know your thoughts on 3D printing in construction.
Construction right now is a bit costly because it is still taking up, but within next 3 to 5 years, I see it going in a big way for especially for individual houses, small places where even farmhouses where you want to build a small house for yourself, where you don't have a manpower, there is a limitation because speed is one thing. It is a great using if you're using a 3D printer, you can build a house in very short time. Right now, as any technology which we started, as I told you in 96 when we started FDM, that time also the raw material cost was too high. Similarly, for construction, right now it is costly compared to your conventional, but yes, down the line you will see a greater adaptability on construction being utilized 3D printing. For example, I would like to tell recently few bunkers were made for Indian Army. The advantage was they could make hollow bunkers because of the technology. They could put in gaps in between in a bigger way so that the strength was achieved, but with a lesser weight. So again, vis-a-vis what application you are using, uh, the it is going to work that way.
Okay, and Miss Sulakshana wants to know, she wants to know about OEM names of 3D printers.
Uh, there are many companies like 3D Systems, EOS, Stratasys, Markforge. Uh, these are few bigger names. Then for metal, there are SLM. Even metal Indian companies are there which are uh, coming up with metal machines. And in next few years, maybe we will be looking at Indian metal machines being installed in a big way, which can bring down the costing and the prices in a affordable way.
Okay. So, and another question from Mr. Prashant, FDM, SLA, SLS, which is best?
See, as I explained you, if you're looking for cost, FDM is best. If you're looking at strength, SLS is best. If you're looking for surface finish and detailing, SLA is the best. So you cannot compare apple to apple. Like these are all different technologies. So it's like trying to compare a Maruti with a Mercedes or a Ferrari. They have their own USPs. So it will all depend on what you want to use it for. They have their own pros and cons. Every technology has a pros and cons.
Okay, he also wants to know that what about the porosity we observed in 3D printing parts?
Yes. If you look at FDM, you will find maximum porosity, then SLS. Uh, SLA will not have a porosity. Even MJF has a reduced porosity compared to SLS in a bigger way. Uh, as and as the technology keeps on evolving, the porosity will definitely go on reducing.
Okay. He also wants to know some machines for prototype printing and the raw material source.
That I think we can discuss it offline. So you can take down his number and then yeah, our AIM Tech team can connect with him.
Sure, we'll do that. The next question is from Mr. Rajendra, and he wants to know the budget for setting up a 3D printing for machines, materials, and manning, etc.
Again, it will depend on what type of setup you want to come up with. If it is just FDM, you're looking for local FDMs, or you're looking for branded machines, you're looking It's very vague. Hmm. It's it all depends on what you want to set up. See, if I give a typical range, FDM machine today, a low cost FDM machine costs around 25,000 rupees. And a Stratasys machine, FDM machine, may be costing around 1 crore rupees. Similarly, an SLA machine, if you go with a Formlabs, a desktop Formlab machine, which costs around 3 or 4 lakh rupees, to a Chinese machine, maybe 40, 50 lakhs, to a 3D system machine, which may be costing around 80 lakhs to 1.5 crores. So it's that. Even in SLS, you have now smaller machines which have come out with 50 lakhs. But again, SLS is the costliest technology. The lowest machine you may get not less than 50 lakhs. And the bigger machines are available at around 2.5 crores, 3 crores rupees. And for metal, currently the machines are very costly. They, I think, are in the range of around 3 to 5 crore rupees. Indian manufacturers are trying to get those machines at around 1.5 to 1.8 crore machines. They are starting up, but it will take some time. But hopefully, we will be seeing below 1 CR machines coming in soon for metal industry also, which will be a very big game changer. Though it is a metal machine, I would say it will be a big game changer for plastic parts. If the metal machine costs come down, the more and more tool rooms will use those technology for making conformal cooling inserts, and we would see better molds being developed, and people not going to China for making the molds.
Okay, next question. Mr. Siju George wants to know how about Indian, like Indian made 3D printers.
Yeah, that is what I told. Like, if you see, for plastic polymer machines, we have very few handful of people manufacturing machines. But for them also, scalability is a very big issue. Uh, Today, we have some brands who are providing Indian polymer machines. But if you compare those machines to a Chinese brand where that scalability is going to be a challenge for them, because a Chinese machine is available at 25,000 rupees, an Indian machine being manufactured and sold not less than 1.5, 2 lakh rupees to start with. That challenge is there. Metal, yes, as I told you earlier, Indian companies are working on the metal machines, and that definitely the price range at which the manufacturers right now are trying to get those machines, it will be a game changer. It's only we have to wait for some time till the machines are stabilized and uh, are in running for a few time before people uh, trust into investing those machines.
Okay, so last question. So are 3D printed goods as good as those manufactured traditionally?
Certain wherever we are using certain materials, yes, definitely, but you cannot directly compare 3D printed parts with final molded components. Metal components, yes. See, today aerospace industry or defense industry is using metal parts directly, which has better strength, lower porosities, and they have been able to achieve their targets of reduction in the weight. For plastic, for certain applications, yes, but if you generalize, then no, definitely no. We are still long back. We are still to cross a long way ahead to get actual materials to be 3D printed. As I told you, there are technologies, people are working on it, that you just put in a pellet in the hopper and you 3D print in whatever material you want. There is going to be some challenges, some limitations in the over the years. We people are working on it. We never know they will come out with something much better than what we are getting today.
So there are some questions from like about the cost, about metal machines, and then about the finished operations, painting, then the finished accuracy and everything. But I think we also have a time limit. I would love to take all the questions, but I think we have a time limit over here. So yeah.
So before I would one answer I would give for finishing. See, definitely when you're finishing and painting a part, you're adding some raw material to it. You're adding some surface thickness to it. Uh, so depending on the technology you selected, if you have selected an FDM part and you're doing finishing, definitely you're going to lose the accuracies or surface geometries because you have to apply more of putty and do the finishing. Same thing if you are using an SLA sample for painting, definitely you will get a better surface finish without losing on the part geometry. Even orientation of the parts makes a lot of difference. I would like to give an example of a pen. A pen can be oriented in different orientation. It can be made in flat. You can load it vertically with a height of maybe 150 mm, which will give you the best finish. If you load it flat, the print job may get over within an hour, but you will see the layer marks because every 3D printing works on a layer technology. So that pen, the mass is same. If you say pen is going to be the same, the final output is going to be the same. Either I bit it a flat or in the Z direction or in the Y direction, but the surface finish is going to be drastically different. So it will again depend on what is your application. If for you finish is important, you will build a pen in a vertical direction. It is going to go at least 150 mm. So you know it is going to take maybe horizontally it was going to take 1 hour. Here it is going to take 5 to 6 hours. So then if the time is increasing, your cost is going to increasing. But a trade-off is that you will get a better finish part with minimum finishing to be done, and maybe after you paint it, it will not lose its features.
I would like to thank all the panelists. Thank you so much, Paresh sir. This was a wonderful session. Kushal sir, thank you for answering most of the questions in the chat. And Ms. Amaya Jadhav. And last but not the least, our Mr. Mayur Kesha sir. Thank you so much for coming. And we appreciate your time and efforts. Thank you.
I would like to thank the participants for raising so many questions. So at least they were physically and mentally both available or present over there on a Saturday lazy afternoon. I would, if there are still questions, I would definitely like to answer it uh, offline. You can uh, share my number to them. Whoever wants, they can connect to with me later on. I can definitely help them out wherever and in whatever way possible. Thank you. Thank you. Yeah, you
Thank
can
you.
note down my number. It's 9821. Can someone put on chat, please?
Yes, I will do that.
Yeah. Thank you very much.